Okay, for number 88, looks like a trig substitution. And let's go through that. So the first thing to do is, you know, this looks like it might work out pretty nicely. And I'm just going to say x equals 2 tangent theta. Dx would be 2 secant squared theta d theta. And just plug it in and hope for the best. All right, what do you get over here? You get, let's see, you get the root. And that would be, x squared would be 4 tangent squared. And then plus 4. What's x squared? It's going to be 4 tangent squared. And what's dx? It's going to be 2 secant squared. Let's see, theta d theta. What are you hoping for? Things to work out pretty nicely. And let's take a look. And I noticed that the top of 4 would pull out on the radicand. And square root of 4 is 2. And 2 times 2 is 4. So the numbers cancel off. All right, that's not bad. Then you get left with tan squared theta plus 1, which is going to be secant squared. Square root of secant squared is secant. So what are you going to get? You're going to get secant cubed. What do you get in bottom? Tangent squared. All right, so I'm going to say, you know, I'm not sure if that gotten any easier for me, but I'm looking at this thing, and it might be a good idea to write things in terms of sines and cosines now. Who knows what's going to happen? And what do you get over here? And I got to be, you know, sort of careful with it. I'm going to divide the top and the bottom by secant cubed. So you get 1. And at bottom you get tangent squared over cosine squared, which is, you know, let me write that down. You get sine squared, cosine squared. That's what tangent squared is, by the way. And I'm dividing by cosine. I'm sorry, I'm multiplying by, I'm dividing by secant, which is like cosine cubed. Okay, I'm sorry. And what do you get there? You get sine theta, sine squared theta, sorry. And what else do you get? You get a cosine. All right. Before I go on with that, I want to make sure I did the right thing. So we're here, and what I did was I divided top and bottom by secant cubed. So that's going to be 1, and that tangent squared is sine squared over cosine squared. And dividing by secant cubed is like multiplying by cosine cubed. So yeah, I'm okay with that. Sine squared, cosine theta, and then I got that. I'll write this over here. Then the question, what are you doing with that? This is where I probably would get stuck at this point. All right? Now, granted, if you get stuck, it's nice to say, you know, hint, 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 and you try something different. All right? Let me put that down for you. And, you know, if a student gets there and said, could you give me a hint in this? And I'd say, oh, rewrite the 1 as a Pythagorean identity. Let's take that down. What's a Pythagorean identity for 1? It would be sine squared plus cosine squared. Hint, hint, so to speak. And then I would probably split into 2 integrations. And it's the first integration would be sine squared over sine squared. That would just cancel off. We left off with secant theta d theta. I'm sorry, I didn't mean to do that. So what I did, I just did this divided by that. And it's going to be plus now. And that's going to be cosine over sine squared. I'll write that down. Cosine. I'll write down cosine theta over sine squared. D theta. That's not so bad, right? I recognize something right now. I recognize I do know the answer for the secant theta, and this seems like a theme of this guy's problem set. So what's that going to be? The natural log, absolute value, secant theta, plus tangent theta. Okay. The second guy, I'm starting to see something now. Might be different when I did the notes, by the way. That doesn't matter. I'm going to let u equal sine theta. That means du would be equal to cosine theta d theta. Before I go on, I want to make sure I'm saying that right, though. Yeah, I think so. Put this over here. And I'm seeing du. And then I'm u squared in the bottom. Let me keep moving. Natural log secant theta plus tangent theta. Let's see, that's going to be u to the minus 2. So it's going to be u to the minus 1 over minus 1, so minus, plus some constant integration. And I got a couple of things to go backwards on at this point. All right, put a little star over here too. Sure, I'm doing okay with that. But I made a couple of substitutions, didn't I? Got to go backwards. And let's see if I can do it. What's u? It's a sine of theta. And sine of theta to the minus 1 is going to be cosecant. Okay, let's see if we can do it. And one step at a time. And I got to remind myself. And let's see if I did this right. Yeah, we're at thetas now, right? Let's see if we can remember what I did. Oh, yeah, x equals 2 tan theta. So x over 2 is a tangent of theta. Let me do my little right triangle. This is theta. This is x over 2. This is the root of x squared plus 4. Let's see if I can write that down now. Natural log, absolute value. Let's see, the secant of theta is going to be the square root of x squared plus 4 over 2. The tan of theta is going to be x over 2 minus the sine, the cosecant of theta, and that's going to be the square root of x squared plus 4 over 2 plus c. I think I'm home safe at this point. I do want to point out, I look at the key, and I notice the key looks a little bit differently, and we'll discuss that with you. All right? So let me just see if I made any other mistakes over here. 2x. You know, I think I might be made a mistake somewhere, so I got to take a look at it. Secant theta, u squared u. I think I made a mistake in the cosecant. That's where I was coming from. So it's going to be, yeah, it's not over 2, it's over x. My mistake. Let me get my eraser out. I'm glad I looked at the key, by the way, because I don't want to put something that's not correct. I made a mistake there. I made a mistake in writing this thing down. All right? So let me, I made a mistake here. I just corrected the mistake over here, by the way. Now, granted, I want to look at the key again, and certainly I realize that I do have some issues with it. And the one thing I want to point out to you, and again, it might seem strange to you, but be aware of this. On a multiple choice exam, they might try to confuse you. All right? Now, certain says, why would they do that? I want to see if you understand logs. So this is going to be the natural log of the absolute value of x squared plus 4 plus x minus the natural log of 2 minus the square root of x squared plus 4 over x plus c. And what they did was they took these two things here and just called it another constant. I'm going to call this C1, and I get another constant over here. So what do you get? Natural log and it's going to be minus common denominator x over here, put the x there, plus c. Let's take a look. If I got the answer. I'm seeing this, seeing this. Yeah, we're good to go. All right, thank you.